All right, so before we get going, let's answer questions on 9.6 and 9.7. If there are any. It was only the bottom, like 8 questions on 9.6, which I'm going to be honest should have been easy. And then any questions on section 9.7?
They were both pretty easy.
They were both pretty easy? Well, you're welcome then, I guess. Nobody? Yo.
I'm confused on, I don't really know, it's one of the C's. It's like the 4th C, or the 5th C or something.
The 5th C?
Like the last C.
Oh, I got you. Okay. So it's 9.25, and this is questions 9.7 and 9.8. So the last C, so the negative pi halves.
I don't know what it was. All I know is it turns into 90 degrees.
Okay, that's a great question. Okay, so this is, we're just going to call this the last C. And it says determine the quadrant in which, and it gives me negative pi halves, right? Well, negative pi halves is going to be right there on the axis, right? So when it asks you which quadrant is that in, what do you say?
In between, I said quadrant 4. 3 and 4.
I said 3 and.
None. It's not in a quadrant. The only other acceptable answer there is that it is on the what?
Axis.
On the axis.
Wait, so we write on the axis or none?
Yep. They're the only 2 answers I will accept. My other class asked that question when I taught it, so I forgot that you guys didn't. So, okay. Does that make sense, Medley?
Yeah, I think.
Anybody else got a question? So apparently it was easy, whoever said that. Alrighty, so we're going to keep rolling on. We're going to do sections 9.8 and 9.9 today. So it is still 325. This is SM2H, unit 9.8 and 9.9. Our objective is going to be able to determine coterminal angles and expand the trig ratios. Okay. Now, what we're going to do is 9.8 might be, I don't know, the easiest assignment I've ever given, which is what?
Really?
Actually, yeah. I mean, if there's one thing I would say I am, Luke, I'm pretty honest. You know.
Okay.
As long as your name's not Christy, you know. So, how many got that joke? Yeah, that was funny. You didn't laugh, you suck. Okay, now, who can tell me what it means to be coterminal? Anybody? Well, look at the word. What's it? What? Goes together.
Terminals in the airport.
Okay. So, I mean, she's got a point. The terminal is where I stop being on the what?
Axis.
But on the ground and I start to be in the air, right? Terminal comes from terminate, which means to terminate means to end. Okay, so coterminal simply means 2 angles that end at the same place. Okay? Now, what they're going to want is they're going to want one positive and one negative. So let's start off easy, and I say find 2 angles that are coterminal to, somebody throw me out a number.
65.
What is it?
65.
65 degrees. Okay, so this is what, in the big picture, this is what I would like to see you do. Now, I realize that most of you aren't going to do it this way because this is just way easier than that, but this is the idea. So the first thing I'm going to do is I'm going to find 65 degrees. Where's 65 degrees at?
The first
You mean somewhere in quadrant 1?
Yeah.
So let's say that is 65 degrees, right? Now, I want two angles. I forgot to write in here. And they're going to want one positive and one negative. That and at that same place. Now, it's easy to find the negative. I'm just going to go where? I'm going to go the other way, and I'm going to do that. Now, how am I going to figure out what that negative angle is?
Subtract 65 from 360.
Subtract 65. So if I go 360 minus 65, I get what? 295.
And then make it negative.
Okay, now, we want to avoid that because what usually happens? Anybody know? You're right, I'm going to make it negative. The problem is sometimes I forget to make it negative. So is there another way I could write this that would make it a little easier? Except I would just do this. Wouldn't it be easier just to go 65 minus 360? And that's going to give me negative 295. And that's one of them, right? Now, how am I going to find the other one? I want one positive as well.
Isn't it 65?
But I got to have, it's got to be different than 65, yeah.
Add 360.
Yeah, I'm just going to go around once and then back at it. So now I'm going to take 65 and add 360, and that's going to give me what? What is it? Close.
Negative 14.
No, 425 degrees, right? We're talking about the measure of an angle, right? So, in the big picture, all you have to do is subtract 360 and add 360. Now, what if I did this, though? Let's say I said, same idea, find two angles, one positive and one negative. Got the N and the E there for some reason. And one negative that are coterminal to negative 450 degrees. Okay? So again, I'm going to go and I'm going to find where is negative 450 at. Anybody know? Oh, did you not hear me say something earlier? This is how I would like you to do it, but we both know that's probably not how it's going to be. But this is how I'm going to teach it. Okay, who knows where negative 450 at?
It's on the y-axis on the bottom.
So it's going to be like this,
No, go all the way around and then hits right there.
like that. Is that negative 450?
Yeah.
Yeah? Okay, so let's say I want to do it like Stager suggests. What would I do with this? I'm going to take, just like we did last time, I'm going to take my angle, which is negative 450, and do what to it? I'm going to add and subtract 360. So I'm going to add 360 there. I'm going to take negative 450, and I'm going to subtract 360. And what are my two answers?
That's negative 90.
This is negative 90, right? And this is negative, what? Negative 800? 810? Negative 810. Now, what's wrong with that?
Oh, negative.
Yeah, the top one is still negative, and I specified that you need one positive and one negative.
Can't do it.
So what do? Yeah, you just keep adding 360 until you get where? Positive.
Oh.
So I'm going to take that, and I'm just going to add 360 again. Now that's going to get me 270. Now I am positive. Okay? Now, raise your handy. Okay? Did you say already?
Yeah.
Well, I just heard someone say that exact word. One of you said it. What'd you say? This is easy. It's like we need one of those red buttons that says that. You guys know what I'm... Yeah. Okay. So I want two angles. One positive. And one negative. That are coterminal to negative 900. And I want 15 hands because I was told this is easy. Say the 25th. Yeah? 1, 2, 3, 4, 5. You're 5, Murray. 6.
I need no.
7. Need 8 more. 8. 9, 10, 11, 12, 13, 14. One more. 15. Alrighty, who was number 9? What do you got for me, Richards?
I got 180 degrees.
You got 180?
Yeah.
For the positive, what's the negative?
Negative 1,260.
Negative 1,260 degrees?
Yeah.
Now, are they the only two answers I could have?
No.
No. In theory, can I go around as many times as I wanted? Yeah, doesn't matter. I would always find the two that are the what? Closest. Okay? And so that's that. Now, let's say I ask you the same question. Okay? Except now I want you to do it in radians. 2/3 pi. Okay? How does this change, Palmer? And I called on you because it looked like you were whispering something to Steger, and I thought maybe you knew the answer.
I don't.
Anybody know how this changes things?
Do you have to like find it in the?
Nah, I don't think so. This goes back to what you said. You don't have to. Nobody? You could, but if they give it to you in pies, they're going to expect the answer in pi. So if I convert it, then when I'm done, I'll have to do what? Convert it back, right? Easier than that.
Just add it.
Add what?
360.
No, because I can't combine radians and degrees.
Wow. No.
Yo.
Isn't pi equal to 180 degrees?
Okay, but think. Yeah, so instead of adding and subtracting 360, I'm going to add and subtract 2 pi now. Because isn't that the pi equivalent?
Yeah.
So I'm simply going to add 2 pi to that. I'm going to take 2/3 pi and I'm going to subtract 2 pi from that. And I want 10 hands with my answers. Probably need to remind yourself we have 1. Probably need to remind yourself that how do I add and subtract with these?
Oh my.
No one? Say louder. You got to get a common denominator, right? So I got 2. I need 10.
1.
No, I already had 1. That's 2. I need a 3. I'm going to 10. Three, 4. Five, 6, 7, 3 more, 8, 9, 1 more, 10. All right, now do you got a Palmer?
Yeah.
What do you got for my add one, for my positive?
Positive
4/3 pi?
5.
Not what you got?
Wait, no, I forgot to do that one. I just did the negative. That's my.
Well, what's your negative?
That'd be negative 4/3 pi.
Negative 4/3 pi. Is that one right? Okay, that one's right. Somebody want to help him out with the positive one? 8/3? 8/3 pi? Yes or no?
Yes.
Yeah? Okay, one more. Let's do this one, but now we need 15 hands. And if you're one of those kids that never, ever raises your hand, I make a mental note. And I'm just going to start calling on you. Because I can't tell if you're just too shy or you're just sitting there not contributing to society. I mean, right?
Yeah. I already asked you, just don't know it though.
What?
Like, you just don't know it. Like you just don't know how to do it.
I just work too slow.
Me too.
Well, that's okay. But by the time we're done, you should have at least one of them, right?
Yeah, I do.
Okay. So, Daylight, what don't you know about this?
Well, like, I was just confused on the denominator part of it. Don't you already have 3 or something?
Okay, so let's go back and look at this. So let's say I've got the bottom one here, right? I got 2/3 pi and I'm minusing off 2 pi, right? Well, I have to get a common denominator, right? Well, what's my common denominator going to be? 3, right? So if I got to make this 3, right now it's a what?
1.
It's a 1. To make it a 3, I'm going to times it by 3. If I times the denominator by 3, I must times the numerator by 3. So I'm going to get 2/3 pi minus 6/3 pi, right?
Oh, yeah, that makes sense.
Well, 2 minus 6 is 4. My denominator doesn't change. 4/3, negative 4/3 pi.
Okay, yeah.
Does that make more sense now?
Yes.
You're welcome. Yes, Medley.
But like, why 2 pi?
Anybody want to take that?
Equal.
Murray.
Because 1 pi is 180 and 360 is 180 divided by 2, so it's 2 pi.
Oh, there's
Except it's 180
I meant times.
times 2.
That's what I meant, sorry.
Right? We're just doing the exact same thing. We're just doing it in our pi units now instead of our degree units. Does that, you got to move your head so I can make out, does that, okay, all righty. So let's go 15 hands. Actually, just for daily boss, let's go 20. Okay, we'll go 20 hands. And I'm going to go negative, negative 12/5 pi. Do it. 1 positive, 1 negative. And we're going 20 hands, so that's going to be almost up, well, you know, two-thirds of you. Well, not quite. We got like 30 forever. I got 1. And please make sure you remember your number. Two, 3, 4, 5, 6, 7, 8, 9. Opaking, you're 10, you're 11. Palmer, you're 12, you're 13, you're 14. 6 more, let's go. 15, Stager, you're 16. Also, you're 17. You're 18. You're 19. 1 more. You're 20, Will. All righty, Bailey. What do you got for my positive?
I got 8/5 pi.
8/5 pi. Anybody else get 8/5 pi? Okay, so you were number 20. Who was 19? What do you got for your negative, Sid? Say that again. Negative 22/5 pi. Does that work?
Yeah.
Yeah. Now, does anybody have something other than negative 22/5 pi? What do you got? Negative 32/5 pi?
We had it twice.
I think that would work though. Yeah. But what I realized is this. If I'm doing the positive version first, I would have went negative 12/5 pi times, and I would have just done 10/5, right?
So you could have just done -2. Oh, okay.
Yeah. Now, if I would have done this, isn't that negative 2/5 pi?
Yeah.
Isn't that also a negative 1?
Yeah.
And I've already had that answer. Some of you all had that answer already. Is that a negative coterminal angle?
Yeah.
Yeah, would I have even had to have done the second step? No, because I already had one of them. Does that make sense? Just like a little... Alrighty, so that's that. Yo.
We don't put them in mixed numbers, do we?
Ooh, great point. No. Leave them improper. Leave them just like we have them. Okay? These were our two. And that's just because kids screw it up where the pi goes and stuff. Leave them as impropers. Okay? Alrighty, now we're going to go on to 9-9. And this is more unit circle stuff. Now listen. This is really, really easy. Assuming you have your unit circle still. Because everything you're going to do is going to be based upon those values. Now, I'm hoping we all checked it, and if we were wrong, we fixed it. Because you're going to use that. You know what I'm saying? Now, we already know sine, cosine, and tangent of theta, right? What's sine?
Opposite and adjacent.
Opposite over adjacent, right? What's cosine?
Opposite over.
Whoa, sine's not opposite over adjacent. Sine's opposite over... Who's leading me astray?
Opposite over.
What's cosine?
Adjacent over hypotenuse.
And tangent is opposite over adjacent. Now, each one of these have an inverse function. Okay? Sine has an inverse, and it is called cosecant. CSC. Well, if sine's inverse is the cosecant, what do you think the ratio for cosecant is?
Hypotenuse over opposite.
Cosines is secant, and it is,
Hypotenuse over adjacent.
and tangents is cotangent, and it is
Adjacent over opposite.
adjacent over opposite. Now, all you have to do is get out your unit circle, okay? And it's going to give you a measure, either in degrees or in pies, it doesn't matter. You're going to fill this chart in. Now, these are easy. Well, how do I get the others?
Would you just flip it?
Say that louder.
Would you just flip it?
Just flip it. What's the only thing you got to watch for?
Big simplify.
Close.
Square root.
Starts with an R.
Right.
Rationalizing the denominator. Okay? So what they're going to do is this. Is they are going to go, and let's start out. Let's say I gave you the cosine of 135 degrees. Okay? Now, or sorry, they're going to give you just 135 degrees. Okay? And then they're going to want the sine of 135. They're going to want the cosine of 135. They're going to want the tangent of 135. And then they're going to want the cosecant of 135. They're going to want the secant of 135. They're going to want the cotangent of 135. Now, all I've got to do is take my unit circle right here, and I'm going to go and I'm going to figure that out. So look, I'm going to go find 135 is right there, right? Correct? Now, I got to remember where my numbers are at. So, if I'm looking at 135, I'm looking right here, right? Because I always make it with the horizontal, right? So I'm looking at this triangle right here. What is this going to be on this triangle? Isn't it root 2 over 2?
Yeah.
Right? Because that's my y value. What's this going to be?
It's going to be
Negative 2 over 3.
Negative root 2 over 2, because that's my x value, right? What's my hypotenuse? My hypotenuse is always 1, right? So now I've got my sides. So I'm going to look at this and I'm going to say, okay, that's my triangle. So sine is opposite over hypotenuse, right? So that's going to be what? What's opposite it? I'm looking at this angle. What's opposite it?
Right over 2 over 2.
So I go root 2 over 2. Root 2 over 2 over, what's my hypotenuse? 1. Well, what's root 2 over 2 over 1? Yeah, just root 2 over 2. That's what the sine of 135 degrees is. Okay, now cosine is what? Adjacent over hypotenuse, right? So what's my adjacent number? Negative root 2 over 2 over 1, which is just negative root 2 over 2. And that is now the cosine of 135. Now what's tangent going to be? Opposite over adjacent, isn't it? And it's root 2 over 2 over negative root 2 over 2, which is just negative 1. Now, I'm going to come over here. And all I'm going to do is what? I'm going to flip it, right? So, here's my answer. The cosecant is the inverse of that. So I'm going to just write 2 over the square root of 2.
Wait,
What-
what about the 1? Wouldn't it be 1 over?
Doesn't matter. No, we simplified that. It's still the same thing. Just flip this.
So you can't do that. So wouldn't it be square root
2 with 2
square
square
root
root 2 over 2 square root 2.
Wouldn't it be just
Wouldn't it be square root 2 over square root 2?
What?
What are you saying, Palmer?
Think of how-
Why is it just the square root of 2?
Because after it comes out,
Because when I go 2 over the square root of 2, I believe I just said you had to make sure you did what? Rationalize it, right? Root 2 and root 2, that's going to give me 2 roots of 2 over 2. Well, what will those 2's do? Or reduce, right? Which is just the square root of 2. So what about the secant of 135? Negative square root of 2. Because notice, sine and cosine are the same thing, just with different what here? Different signs, right? Well, same thing with different signs, right? What about the cotangent?
Isn't it just 1?
negative 1.
Just 1. Positive 1.
We're not having another negative.
Oh yeah, I guess you're right.
The sign doesn't change, just a fraction. But it isn't going to matter because it's going to be negative 1. Yes?
So if you plug like sine 135 into the calculator, would you get something different?
So what you'll realize here, and that's actually a really good, let me show you something. Everybody watch up here really quick. Okay? Yep, so I got to be in degrees because we're doing degrees here. So let me go down, mode. I'm in degrees. So watch this. She's saying if I go the sine of 135 and I hit enter, right? I got that. Now we said that the sine of 135 was really that, correct?
Yeah.
So watch. What are they?
The same.
Same thing. That's what you're finding. Does that make sense? But you're finding it exactly without a calculator. There will be some of these, and I mean, that decimal does you no good because we need exact answers. Okay? So let's do another one. Let's say I did, well, let me show you something really quick. Everybody write this down right on your paper somewhere. Sine of theta is y over r. Cosine of theta is x over r. Tangent of theta is y over x. Write that down. I probably would write it on my unit circle as well, yes. Okay. And I'll explain why that's important in just a second. What? Last one is y over x, yes. We all got that written down? Okay, so let's say I said this. Find the 6 trig ratios for negative 90 degrees. Okay? Now when I say 6 trig ratios, what am I asking for?
Sine, cosine, and
Those 3 and those 3. Those 6, right? Now, Where's negative 90 at? It falls right on a line, doesn't it?
Yeah.
What can't I generate if it falls on a line? I can't generate a what? A triangle. Right? Because my triangle would go straight down. So your triangles have to be made with the horizontal, right? So, look at what I just gave you and see if you can figure out how to do that.
It's a triangle, right?
It is. No, it's not a right triangle. Look. At that point, do I have an X and a Y?
Yes.
Do I have an R?
No.
I don't?
Yes, you do.
I do. What's my R? 1. No matter what, it's 1. Right? So look at that, and look at that, and is there anybody that thinks they can figure that out? Is your hand up, Daily Bob? Smedley, you think you got it?
Wait, wouldn't you just plug it all, like, I feel like, no, I don't know how to do it.
No, what were you going to say?
Well, I'm just gonna say, like, couldn't we just plug in, like, since we know what the X and the Y and the R are, you could just plug them all in and then flip them?
That's what I would do. So what do you got here?
Sine is Y over R, so you do, 2, or radical 2 over 2, wouldn't you?
Where are you getting those values from?
I thought that's what Y was.
No.
It's 0, negative
You
1.
got 0, negative 1 right here, don't you?
Oh.
I mean, you're like as close as ever.
I'm what?
You're as close as ever, just got the wrong numbers.
Yeah, so, okay, then I know.
So what do you got, Steger?
Well, you just plug the X and the Y's in.
Yeah, so you got what?
For the sine of theta, -1.
Over,
1.
which is just -1, right? What's the cosine of theta?
I just got 0.
0, because it's 0 over 1, which is 0, right? What's the tangent of theta?
0.
0 over,
1 over 0.
or it's actually -1 over 0, isn't it?
Yeah.
Because it's y over r, right? -1 over 0, which really makes that what?
Undefined.
Undefined. Okay? Now, for my inverses, I'm going to have the cosecant, right? So I'm going to go the cosecant of theta is what? -1. What is the secant of theta? It's undefined, right? And then what is the cotangent of theta? Now it's 0. Because my 0 is now in the numerator. So yeah, whenever it lands on a line, you really need to have these relationships. That's why I said write them down on your paper. Okay?
Oh, easy.
Well, if that's the case, let's do one more, then we'll cut you loose. So I want the 6 trig ratios, and I want 15 hands. Okay? So it will say find the 6 trig ratios for negative 270 degrees. No, check that. No, not negative 270. Let's go negative 230, negative 235 degrees. Negative 235. No, check that. We don't want to do that. Anybody know why we don't want to do that? It's the exact same answer, isn't it? Because negative 235 and 135 are what?
Similar.
I just taught this.
They are transversal.
Coterminal, which means all my ratios would be the exact same. Let's go negative.
I forgot what it was.
No, let's go negative 360. What would 45 degrees? What's 360 minus 45? Negative 315 degrees. Find me the 6 trig ratios for negative 315. Daily, you doing this?
I am.
I need 15 hands. Let's go. One.
No.
Oh.
Oh, I have no idea. I was just wondering, like, if it's like if you're finding the empty space or if you're finding the filled space.
You're finding whatever space makes a triangle with the horizontal. So even though I'm going this way, I'm going to find this triangle. Does that make sense, Smedley? Do you have the answer? I have one. Everybody look. Everybody look. So to answer Smedley's question, 315 takes me around to right here, right? But I'm going to use this triangle. So I'm always using the triangle created with the horizontal. So I'm really using that as my X, that is my Y. Does that make sense? So where are we at? Who's got her hands up? So I had one. Who was my one? I didn't have a one?
Who is one?
Stager, you were my one, right? So who's two? Raise your hand. So 2, 3. I got 3. I need 12 more. So you're 4.
Yep.
How do you get that?
5, 6.
I guess.
Did you just turn my light on?
I guess.
7, 8,
Where do you,
9.
Where do you, no, don't. Where do you put the theta?
Theta is just this. The sine of theta. Theta is this angle now.
How do you get the numerator to stay radical out of the denominator?
You rationalize the denominator. Who was my last number? What number were you? 6? 3? No, we were past that. Who was my last number? Kaya, what were you? You were 9, so you're 10. Am I going to get 5 more?
I doubt it.
You doubt it?
I'm really, really lost.
I actually understood this one.
So you're 11? 12? Am I going to get 3 more?
Come on, people. Come on, G. G, you can do it.
Negative? 13, 2 more. 14, 1 more.
Come on, G.
All right, well, that's 4 enough. Let's go. So, Charlie, what did you get for the sine of theta? Shh. Root 2 over 2. Anybody else get root 2 over 2?
No.
No? Who got root 2 over 2?
It's negative
Okay.
2 over 2.
I don't think so. Okay. Shh. Okay, so what number were you? 5. Who was 6? What do you got for the cosine of theta?
Root 2 over 2.
Anybody else get root 2 over 2?
What the?
Okay, so what number were you?
I was 6.
Who was 7? What do you got for tangent?
Isn't it just one?
Is it 1?
Yeah, negative one.
Negative 1? It's got to be positive.
Negative 315. What you did is you just went right to 315, but you should go reverse around.
Oh.
Okay, so what were you? 8? 7. Who was 8? Who was number 8? What do you got for me, Smedley, for the cosecant of theta? Root 2, is she right? Who was 9? What do you got for 9, Kaya? Root 2, and who is 10? What do you got, Sydney? Are they right? Just like that.
Dang.
Did you get it, Bailey? Makes you feel good, doesn't it? Yeah. Yeah. Okay, time is yours. Use it wisely. Got about a half an hour left. You should be able to do a lot. Now, I'm going to be honest. If I was you, I would start on 9-9 while you're in class, because the other one I thought was easier. I mean, Murray said it was easy, right? So I would start on the harder one. That way, if you need some help, I know a guy that can help you. Yeah, Stager's right there. Yeah, that was funny. You're welcome. We had our 2 triangles, 30, 60, 90, right? Okay. They were x, 2x, and x roots of 3, right? When we did those 2 special triangles, like 9, 3 or 4 or something. Then we had 45, 45. Yeah, we did all this. Hey, what section were the 2 special triangles? Anybody remember? 9-5, I think. It was the date. It was the section before the unit circle. Dinsdale. Right there. Oh, is that now? Oh, I see how it is. Oh, that's not that. That's next week. Oh, okay.
Why is the X over
Because that's the ratio it always is.
Like, that's just like a fact.
That's a fact. That's a fact. That's where they come from. So what we did is in the unit circle, now this is 1. Okay? So we go from here to there. I'm going to divide by 2, so that's now 1/2. We go from there to there. I'm going to times by the square root of 3. That gets me root 2 over 2. Because it always follows this pattern.
Oh my god.
Oh my.
Whenever my short side is, it's opposite my 30. To get to my other side, I just times it by the square root of 3. It always works out. Those numbers will never change.